Welcome everyone, thank you for joining. This is Crash Course in Kubernetes Monitoring. My name is Robert Munteanu, and for the next 30 minutes I'll be sharing my experiences about monitoring and Kubernetes and all that. A bit about myself. I work for Adobe in Basel, Switzerland. I'm in the Cloud Foundation Core Services team. My work focuses a lot on Java, Kubernetes, web applications, mostly on back-endy, frameworky stuff. I'm also a member of the Apache Software Foundation, involved in a couple of projects, notably Apache Sling, Apache Jackrabbit. Now, for today, we'll have the following structure. We're going to be talking about monitoring concepts, just to make sure we're on the same page when it comes to vocabulary and what we mean by things. Then we have the whole metric stuff, generating them, collecting, aggregating, and then publishing them. We're going to do the Kubernetes integration next. How does Kubernetes fit in the whole picture? And we're going to end with a demo. Now, monitoring as a general purpose, as a general thing, is a good idea, obviously. But there are simple systems. Sometimes they are simple, isolated, or not mission critical. So you can get away without doing too much monitoring work. I used to do a lot of what I called top monitoring. I would log into the server, run top. You had a small load average, everything is fine. So monitoring worked. Or maybe you had a high load average for the application server, which meant you looked at the application code. You had a high load average for the database server, so you looked into your queries and your indexes and what was going on there. But on the other hand, there are systems that are more complex, they are important, they are interconnected. And for those, you need special monitoring. You need to build them from the ground up to be observable. You have to expose various metrics so that both developers working with the systems and, just as important, operators maintaining those systems in production will be able to quickly diagnose the state of the application, what is going well, what is going wrong, and what actions they should take. And this is where the whole monitoring comes into play. By generating useful and actionable and easy to understand dashboards, you can help everyone that is going to work on your application one way or another. So what are metrics? The simplest way I see them, they are an atom of information. They tell something about your application at a given point in time. And really, the simplest thing that you can think of is my application running? Yes or no? No, there is no maybe here. So there's a start. But then you have to ask yourself, when? Is my application running right now? Was it running 5 minutes ago? Was it running 2 weeks ago? So you need to attach a timestamp to a metric to be useful. And then it becomes interesting if you want to attach other kinds of values to the metric. Where was it running? So was it running on host A? Was it running on host B? Because then you start to analyze. I wanted my application to be running on 5 hosts. Why was it running only on 3? So these are like the rules of the thumb for defining metrics. Optional but highly recommended is that you make your metrics atomic. So if you can have 2 metrics and you can calculate a third out of them, don't create a metric for that, just calculate it. Usually people do this for performance reasons, but there are ways around it. Don't compromise on the design of your metrics. So what does a monitoring architecture look like? Well, first thing, you have your application. That's the basic premise. And then you have a metrics component somewhere where you collect all the metrics, all the runtime information about what is going on in your application. And then you get a metrics repository that either pulls metrics out of your application or your application pushes the metrics to that repository. It's either way, it doesn't really matter. And then you have 2 other important components. One is alerting, which means that if you have all those metrics, you'd better make sure that you have some warnings, some alerts going out when something goes wrong, when some metrics start to fluctuate widely or go out of their bounds. And then you have this dashboard or the reporting component, which means that you can, at any point in time, get a useful report on the state of the application. Good. Now that's done with. Let's talk a bit about generating metrics. Usually, if you start off by saying, okay, I want to add some sort of metrics to my application, and you say, I want a counter for the number of login events. And that is usually, you think, okay, that's quite simple. I have a long or an integer somewhere, and I keep incrementing it on each login event. But then you realize that you have to design an API for it, and that you probably want thread safety, that you are going to be thinking about adding more interesting metrics. You want to do histograms, you want to do some sort of distribution, you want to compute, I don't know, sliding window metrics, and reporting is not good enough just to use JMX. You want to integrate with some other system, and so on and so forth. And then you decide, maybe I should have used a library. Now, the most popular, or maybe one of the most popular libraries in the JVM world is the Drop Wizard metrics, and you basically cannot go wrong with that. The API is actually quite simple. You have a metrics registry, and then you pass that reference everywhere in your application, and you generate counters or gauges or summaries out of it. All of these, the API is thread safe, so you can reuse the registry and the metrics generation code everywhere without worrying a bit. Reporting is also quite simple. You have various reporters. You have some console and some JMX reporters built in. And there's a variety of community contributed reporters as well. So that's usually my go-to solution for generating metrics. Now, what about collecting them? This is where the metrics registry comes in. The solution I see most often used is something called Prometheus. That's an open source monitoring solution. And it's what they call a graduated project of the Cloud Native Computing Foundation. I always get my acronyms wrong. So what that means, besides a seal of trust that is a healthy open source project, is that it works well with Kubernetes and Containerd and other projects that are part of this Cloud Native Computing Foundation. But the most interesting part to me is that it's backed by a time series database. Now, if you have some background in statistics or econometry or something similar, you may remember time series as a series of values that are indexed or ordered by timestamp. And while you could use a general purpose database for storing monitoring data or metrics in general, it becomes inefficient. So a time series database can be extremely efficient in recording additional metrics data. Instead of creating a JSON document or a whole row for a new metrics value, it is able to append just a couple of bytes of storage on disk. It doesn't have to handle deletes. It doesn't have to handle updates. It always writes ahead. And that means it can scale out to much, much larger repositories of metrics. Additionally, the querying language and the functions and the operators that it uses are very much optimized to generating metrics data and reports on that. So if you want to find out what has been the increase of the request per second for the last 30 minutes aggregated by application server, it can do that in a very easy and fluent and efficient manner. I can't say the same for general purpose databases. So it's just very well suited for that kind of work. If you want to get data into Prometheus, the classical solution is to have an HTTP endpoint in your application somewhere and dump the metrics data in a very simple text-based format. The minimum requirement is a metric name and a value. Here we can see we have served a total of 42 requests so far. There are some comments. You can add a help text that is currently not being interpreted, but it's there for future use. A type, currently a counter. So a counter is obviously a value that can only go up. And then you can write some other comments that have no meaning whatsoever. You can attach some labels to this metric. So in here we say we have the requests that have generated 200 status code response and have been a response of a get verb. Now those are 22. Another type of metrics are gauges. Now gauges, as opposed to counters, can go down as well as going up. You may say, okay, what's the big deal? So they can go down. Well, usually counters can happen to be volatile, right? So they get lost on application restart. So you have served 500 requests, your application goes down, and then you restart at 1. If Prometheus knows that this is an actual counter, it will know that it should not roll over and just continue adding values on top. So that's useful. And it also has support for more, let's say, structured or more complex metric types like histograms. Now here what we see is a distribution of how fast the requests were completed in our application. So we have some buckets or segments. So we can see that no requests were served faster than half a second. One request was served faster than half a second. And then 2 requests faster than 2 seconds. And these buckets are cumulative, which means that out of these 2 requests, 1 was served between 0 and 1 seconds, and actually 1 was served between 1 and 2 seconds. So you can get richer metrics out of that. And if you want to get data into Prometheus and you're not using this the default metrics in your application, just want to connect something to it, there is a wealth of exporters either from the Prometheus project or contributed by someone else. Now I ran out of space to add them all. There's a large number of them, and it's actually quite easy to contribute custom exporters. You basically have to expose the HTTP entry point. And although not necessarily recommend, there are solutions to short-lived jobs. You can even dump files on disk if you prefer to do it that way. It's quite easy to get data in. Now, once you have that data, you probably want to look at the metrics, see what happens with your applications. And Prometheus comes with a web UI. It's a console that is mostly useful for debugging and developing your queries. Here you see a listing of the up metric, which is like the answer to is my application available or not, which Prometheus records without any special work from you. If it scrapes your application, it also records this up metric. And since this is a Kubernetes cluster, there's quite a large number of applications, which is not very useful. So let's do a bit of filtering. Now, what we did here is we filtered by the app name Sling, which is the application we're testing, so we can see a lot fewer entries. But again, that's maybe not that useful. So what we can do is apply an average to that. And let me explain why. The up value is either 0 or 1. If the application is down, the value is 0. If the application is up, the value is 1. So if we take an average, we find out the number of applications that are actually up. So at 0.5, it means that half of our applications are up. And then this screenshot was taken immediately after a startup. So it goes up, and then it lands at 1. So right now we know that our applications are available. You can do something called rate, which measures the dynamics, the evolution in time of a certain metric. So here we take the total outgoing network traffic that is going out of various containers. So we can see that it goes up and down for various data points. And we do this using the rate function, and it's taking the calculated data over 5-minute intervals. Now, if we want to do something a bit more involved and say, let's not see the individual data for each container, let's average the traffic for each worker instance. We can do that. We're summing by a label, by an attribute of the metric, which says, let's sum by the host name. And here we have 4 host names, and then we can generate the aggregated graphs for each of those. Okay, so we collected the data. Now let's actually do something with it. And as I hinted before, there are 2 ways. There's a reactive and a proactive approach. The reactive approach is generating alerts. The proactive approach is generating reports and having dashboards and then allowing people to look into them. So Prometheus also has alerting features. You can define some expressions which are basically Prometheus queries. Nothing else. You have the same syntax. Everything is precisely the same, and you when that expression is true, an alert is triggered. Now you have a name for it. You have various labels and annotations. You can attach lots of labels to it. This alert is for a cluster memory usage over 25%. Okay, it doesn't make too much sense in the real world, but that's what I had to work with. I had too much memory. So we can see that we have one active alert, and it's in pending because Prometheus allows you to say, well, if you encounter an error condition, wait for so many minutes or for so many seconds before actually triggering an error, because many times these things just heal themselves. Now, of course, it wouldn't be of much use if it just showed the error in a web UI. So Prometheus integrates with many systems, with Slack, with PagerDuty. You can build your own. It can even send you email if you're living in 1999. It's the kind of system that, well, you set up and people will want to find you. They will do everything to find you if there's an alert. So Prometheus gives them that as well. Now, I mentioned that the Prometheus UI is mostly used for development and debugging. So obviously we need some other solution for getting like nicer reports. And this is where Grafana comes in. Now, Grafana is an open source solution that is able to pull out data from many, many data sources, including Prometheus. And I'm using it with good results for dashboarding and reporting. So one type of graph that you can get with Grafana is the same one that you can get with Prometheus. But there are subtle differences, and from an aesthetical point of view, I think this cannot be understated. It's important to have nice-looking graphs. So you have the same line charts, but you actually have a title. The results are ordered in decreasing order on the right side, so you see the most important parts first, and the axes are actually relevant. You don't see 0.1, you see 10%, so you can clearly see that these are percentages. But more than that, something that Prometheus doesn't support is multiple metrics in the same chart. Yay. So here there's an output of total requests in yellow versus errors in green. By the way, I can't control the color, so I'm sorry for representing errors in green. I'm not trying to say anything by that. There's for displaying things which belong to an interval, and you don't want to necessarily to see the evolution in time, but just the current value to see if it's okay or not. There's this nice radial display which says, well, we're at 42%, and you can define the safe areas, which are shown in green, and the warning areas in orange, and the error areas in red. Now, this is one of my favorites. It's called a heat map, and it's very useful for displaying distributions or histograms. So often you're wondering, okay, I know that my 1% request time is so much, and my 50% request time is so much, but how do I put it in a nice graphical representation? So this heat map is read in the following way. So the green segments mean that no requests are falling in that category. So there are no requests between 5 and 10 seconds, no requests between 2.5 and 5, and so on and so forth. And then the closer, the higher the distribution of requests, the more towards purple it goes, right? So in this interval, we can see that most of our requests were in the 10 to 25 milliseconds range, and then it sort of radiated in a evenly distributed manner. So another interesting visualization technique with Grafana. And to sum it all up, you can group all of these indicators into nice dashboards. Grafana has more panels than that, and you can also add text-based panels using Markdown or HTML, so you can add documentations, link to runbooks, and whatever, just to make your dashboards more usable. Okay, so we now saw how everything goes. Let's talk about Kubernetes specifics. So you have Prometheus set up, and now what do? You have the metrics endpoint that that Prometheus understands. Now, what do you do to get data from your application into Prometheus? there are two options here. The first one is to add some custom annotations to your pod or whatever manages your pod, like a deployment or a replica set. And these annotations are in the Prometheus IO namespace. So if you say scrape equals true and the port is 8080, then Prometheus will know that there is a service running on host X and will look for metrics periodically on that pod. And you can give it a custom path if you don't use the default metrics endpoint. And that is basically it. Prometheus now uses the Kubernetes API and will know that your pod is there. The alternative is to use a custom resource definition, which is a service monitor. Now, this service monitor, instead of asking you to put all the labels in your pod, instead defines them externally and usually matches them using labels. So you see a match labels row here, and it says, look for all the app objects with the label app matches example app. And then the endpoints is here, like the web port, the AT port. So when should you use which? I guess it's more or less a matter of preference. If you are okay with deploying your metadata in the Kubernetes, in the pods, that's fine. You can argue that it sort of couples your pod definitions with Kubernetes, with Prometheus. On the other hand, the service monitor is completely isolated, doesn't interfere with what you're doing, but can be less obvious. You have no idea why or how your data is getting in Prometheus if you care about that sort of thing. Now, since I mentioned that Prometheus plays very nicely with Kubernetes, I should mention that it runs a couple of pods by default. The first one is the node exporter. It runs as a daemon set in Kubernetes, which means it's attached to basically every node in your cluster and exposes the hardware information that you would get from your host if you run like the regular system monitoring tools about CPU, the CPU frequency, disk usage, network I/O, all of those things that are gathered automatically for you by Prometheus, and they are fed into the central instance. But besides that, you also have Kubernetes level information. So there's this Kube state metrics exporter that is able to talk to the Kubernetes API and generate metrics based on that. So you can have, for instance, a number of pods running, right? It's evolved this way. You can have how many times did my vertical pod autoscaler kick in? What's the number of services that we have? How many times did we fail starting a pod? So it generates various metrics at a slightly higher level. And if I were to sort of summarize the Prometheus exporters, well, taking into account whatever happens at the Kubernetes level, so there's the OS hardware level, where you have the node exporter that we talked about. There's the Windows Management Interface exporter if you're running Windows containers. If you're doing work with GPUs, maybe with deep learning, I don't know, there's an NVIDIA exporter for your GPU stats. Then you have the Kubernetes level exporters. And in the end, it's the application level where there is like so many exporters where you gather everything. Now, before talking about how to install monitoring into a cluster, I must admit I'm cheating a bit, so I'm not going to talk about the hard part, which is setting up your Kubernetes cluster, networking, routing ingresses, securing, tiller, whatever, right? I'm going to talk just about the monitoring part. The cluster you have to bring yourself, sorry. And actually, as a pleasant surprise, setting up Prometheus and Grafana for a test run is actually quite simple. If you have Tiller installed, or with newer versions of Helm, you don't even need Tiller. You just use this Helm tool, which is a deployment package manager for Kubernetes, and you install the Prometheus chart. You can give it a name so that you know where to look for it. You can put it in a separate namespace. And then the Prometheus deployment is set up for testing purposes. Grafana is mostly the same. I passed a couple of custom values because I want to keep my dashboards between restarts. Thank you very much. And I also add some custom values. Those custom values are mostly used for provisioning dashboards. So the Grafana chart allows you to download dashboards, definitions from the Grafana central repository. You can also save them as JSON files locally. And that's a very nice way of automatically provisioning everything. Now, it's demo time to show you that everything actually works. I could pinky promise or I could do the demo. So maybe I do the demo. Right, so first point is, now this is our custom test application, and there's like a wealth of metrics. And you can see those. Let me increase the size just a bit. So you see the kind of entries we've been talking about, the metrics, the types, there's gauges, there are counters, there's many things. This is the Prometheus console. So you have auto-completion, you can generate queries. So if I want to look at the total time spent processing, I have like this huge amount of information. And let's try to generate like the rate of change, and it should be mostly idle because, well, the cluster hasn't been doing anything while I was moving the slides. And if I want to generate like the whole, to see what the whole cluster has been doing, I can do a sum. And well, it's been doing having some ups and downs in the last hour. This is one of the default dashboards for Grafana, slightly tweaked, so you can have a very good overview of your Kubernetes cluster, memory, CPU, disk usage. You can have like both global entries and then individual usage per pod. And if you want to do custom things, we have here a correlation between the green area is the CPU usage, and the yellow area is the rate of incoming requests. So you take two uncorrelated queries, or theoretically uncorrelated metrics, and you try to validate whether they are actually linked or not. In our scenario, although we greatly increased the number of requests, the CPU usage of the cluster did not increase significantly, which means that, well, either it's doing memory, it's doing network I/O, or we just have so many CPU resources that it doesn't matter. All right. This is basically the final architecture of how a part of your Kubernetes cluster should look like after applying monitoring. So you have your application, you have application containers, persistence containers, and other auxiliary containers from your cluster. And then you have the monitoring namespace. And then you have Prometheus, Grafana, all the exporters, alerting, etc. With that, I thank you for your attention. These are some resources that I find useful when talking about monitoring and Kubernetes and their integration. And I'm ready to take questions now.
If you have metrics and drop wizard, how do you get them out to Prometheus? Like if you can have a graphite reporter which pushes it, but how do you normally expose these metrics as an endpoint? Like, is there a handy way of doing this?
Right, so the question was about exporting drop wizard metrics to Prometheus. How do we connect the two? So for my purposes, I just wrote a custom servlet. It's probably about 50 lines of code. I did that because I'm using a special framework. On the other hand, I know there should be an out-of-the-box integration that lives in Prometheus that is called something like this: simple servlet, simple drop wizard servlet, something like that, which bridges drop wizard and Prometheus. There was another one. Yes, please.
You mentioned with Grafana that you have to give an option to save it, but what about Prometheus? What happens if your Prometheus instances stop? Do you lose your data? Is it only memory? Where does the time-scaling data go?
Okay, so the question was, what happens if I stop Prometheus? Well, it's the Prometheus data is saved. It's just that by default, the Prometheus chart asks for persistent storage. It's a default setting, so it's somewhere on a persistent volume. It stays there between restarts, but the Grafana chart doesn't do that by default for some reason. So it's a question of how the chart was written, the Helm chart. Okay, great. Thank you for your time.